Okay. I think we need to start with the basics. There's a lot of debate, which is the most polluted part of the country, which city is more polluted, is Delhi the most polluted city, what is happening with Mumbai? So what I have done is to put on the map of India, the 10 most polluted city from PM2.5 perspective in 2022. Now, as you can see in this map, which is a very interesting map, by the way, is that there seems to be an Indo-Gangetic plain as far as most polluted cities are concerned, two nodes. One happens to be in Bihar, which is very surprising, that of the 10 top most polluted cities in India, four is in Bihar. And then you have 6 cities, which is around Delhi NCR, which is not surprising. We know this data. This data is widely publicized across the mainstream media, as well as on social media. But if you see, the most polluted city was actually Bhiwadi, which is an industrial town in Rajasthan. And then Delhi, of course. The third most polluted city was Darbhanga in Bihar. And then 5th was Patna in Bihar, by the way. And then you have other cities like Ghaziabad and Greater Noida and Muzaffarnagar. So please keep this map in mind as we navigate this entire issue, that one of the most pollution hotspots in India is actually a state which doesn't seem to be very industrialized, which is Bihar. Okay, so keep that point in mind. But the second point that we all must keep in mind is that air pollution is not only an urban issue. Air pollution is equally bad in rural India. And we now have two most interesting papers which has come out in last couple of years, which essentially establishes this fact that rural India is suffering equally from air pollution as big cities like Delhi. This paper, which was published by Chandra Venkataraman and A.R. Ravishankara and other colleagues, and this paper came out in 2020, which was essentially on outdoor air pollution in India, both in urban and rural India. And they also looked at annual mortality from PM2.5. The interesting part of this paper, and they write in their abstract, that they show that outdoor air pollution is just as severe in non-urban regions as in urban regions of India. And this paper goes into a great detail to explain how rural India is equally suffering from air pollution. And then they provide this information on mortality, essentially showing that 70% of mortality due to air pollution actually is in rural India. Only about 30% is in urban area. So of 10.5 lakh annual mortality due to PM2.5, 7 lakh is in rural India. And only about 3.5 lakhs is in cities. While if you look at the debate on air pollution, it is all about cities. It is all about, frankly, Delhi and Delhi NCR. Whereas air pollution is killing many more people in rural India, according to this paper, than urban India. Then there was this paper which came out just a couple of months back. This was not PM, this was NO2 pollution, which is largely linked to industrial and automobile pollution. And this paper again shows that the NO2 exposure in rural region is as severe as in urban areas. So we are not only talking about particulate pollution being bad in rural area, we are also now talking about gaseous pollution being also a major factor in rural India. So the 2 points that I have discussed with you, first, that you have Delhi NCR is not the only polluted part of India. In fact, Bihar seems to be equally polluted. And the second point that I have made is that rural India is actually as badly affected by air pollution as urban India. And therefore, if you look at the big picture on air pollution, you find that in India, about 80% of the population breathes air that is worse than our national standard. 80% of the population. We only have about 20% people who breathe air which is of better quality than national ambient air quality standards. But our ambient air quality standard is actually 4 times higher than WHO standards. Actually, it is WHO guidelines. It is 4 times higher than WHO guidelines. And therefore, almost all of the country breathes air that is considered unsafe by WHO. And if we really want to solve air pollution, then we have to consider it as an all India agenda. It cannot be Delhi NCR agenda. It cannot be urban agenda. It cannot be Delhi agenda or Mumbai agenda. Air pollution is an all India agenda. I think this is the starting point to address this issue. For a very long time, we have made it a Delhi-centric agenda. Then we moved to Delhi NCR agenda, now Indo-Gangetic plains. But air pollution is now equally bad, if not equally bad, very bad in Western India and parts of Northern and Central India as well. So we now have to think about, if we really want to reduce air pollution, solve this problem, it has to be an all India agenda. And this has been the starting point of our research over the last couple of months. So we have not focused on one region, one city. We have decided to look at the country. But while doing this, we have disaggregated data at the state level. So we do know which state, how much PM2.5 emissions are there state-wise. So that data is also available with us. Now, coming back to PM2.5 inventory of India, again, some basics first. Air pollution is essentially the 2 macro factors for air pollution is one, combustion, what we burn. Pollution happens from combustion. We burn fuel, we burn waste, we burn agro residue, biomass, coal. So our combustion basket is a significant contributor to air pollution. So what we burn is a significant part of air pollution. And the second is dust, which could be man-made from construction site, for example, or which could be natural in nature, wind-blown dust. If you are at the edge of a desert, you will have large amount of dust in your ambient air. So both from natural source and man-made source, we have dust, and then we have combustion, what we burn. Now, it is very difficult to estimate at all India level the inventory of PM10 or PM2.5 on dust, because dust is a very local issue. You can estimate dust in Delhi by doing source apportionment studies and scientific and chemical analysis. You can find out that what percentage of PM10 or PM2.5 is from dust. But at all India level, it is almost impossible. More or less, we will fail to estimate what is the total quantum of PM2.5, the focus of our study, that is coming from dust. And therefore, we have ignored dust. Dust is also a significantly higher PM10 than PM2.5. It is not that PM2.5 is not there, but that proportion is not very high. So we have focused on the combustion basket, what we burn, and therefore PM2.5 emission from that combustion basket. So what are we burning? See, emission, as I said, is a factor of what we burn multiplied by emission factor. Okay, and then the emission factor is based on fuel, the kind of fuel we use, and then the kind of control technology we have to control pollution. This is the basic philosophy of estimating emissions. Now, this is what we burn in India. This is our latest estimate in terms of our combustion basket. So we combust about 1 billion tons of coal. 1,050 million tons of coal we burn every year. Coal has a high pollution potential because it is a solid fuel. The combustion is not complete, and therefore emissions are high. So it is a high polluting fuel. The saving grace is that large amount of coal is used in thermal power plants and big industries who have some sort of pollution control equipment. But some amount of coal is still burnt in domestic, micro, and small scale industry. It is also used as cooking fuel in Eastern India, and therefore there's no control there. So you have direct emission from coal as well. But that proportion is significantly lower than the amount of coal we burn in thermal power sector and big industries. So we burn about 1,000 million tons of coal. Then we use about 350 million tons of residential biomass as cooking fuel. You know, the biomass, about 350 million ton of biomass as residential cooking fuel we use. They have even higher pollution potential than coal because the combustion is less better than coal and there is no pollution control equipment. In 350 million tons of biomass, cow dung, cake, agro residue, firewood, charcoal that we burn as cooking fuel, 350 million tons. Then we burn 100 million tons of agro residue in open field, which has the highest pollution potential. Again, there is no pollution control equipment. We also burn about 150 million tons of biomass in industry, by the way, which is sugar industry, biomass-based cogeneration electricity plants. We burn about 150 million tons there. And in those industries, we have, pollution control equipment. We also have now started using biomass as pellet in food processing industry and other industries. So about 150 million tons. This is a conservative estimate. It could be 200 million tons, but this is broad figure that I'm giving you. We use 125 million tons of oil in transport. Okay. Petrol, diesel, furnace oil, about 125 million tons. We consume about 50 million tons of natural gas, largely in industries and power plant, but about 30-40% as residential fuel as well. And then we burn about 10 to 15 million tons of garbage. Okay. This is the combustion basket of India. We burn approximately 1.8 billion tons of material, could be 2 billion tons. Let's assume 2 billion tons. Of this 2 billion tons, 85 to 90% actually is coal and biomass. So 90% of the things that we burn in India is either coal or biomass. Only about 7-10% is oil and natural gas. And therefore, it is common sense to assume that a bulk of pollution has to come from coal and biomass. It cannot be from oil or gas. I'll come back to this point, but I again want you to keep this basic thing in mind as we progress with PM2.5 inventory. So the third point I am making is that the bulk of combustion in this country, more than 90%, actually is solid fuel, coal and biomass. And therefore, a bulk of air pollution should come from coal and biomass at the macro. That's what a macro analysis will show. But we have gone much deeper. We have done sector by sector, state by state, detailed analysis to understand actually from where this pollution is coming. So I wanted to give you this macro picture before I delve into the micro and details of the PM2.5 inventory. So our methodology is divided in two parts. One is for stationary fuel consumption and industrial process, and second is for mobile sources. So there are two parts to our analysis. I'll go one by one. The basic methodology is the same, which is emission of PM2.5 in tons per year is equal to activity. Activity could be an industrial sector. Activity could be electricity generation in a thermal power plant, where we use coal, for example, and the emission factor for using that energy, using that fuel. So it's activity multiplied by emission factor. Now, emission factor depends on many, many things. I'll give you the example of thermal power sector, what we did. First, we had to classify thermal power sector into different vintage, age bracket, and technology bracket. We have some very old thermal power plant, and we have some very new thermal power plant. And therefore, emission and technology and pollution control equipments are very different in old and new. So first, we had to categorize thermal power sector based on age and technology and pollution control equipment. Then we had to look at amount of electricity being produced from different bracket, different age group. Then we had to estimate emission factor based on what is the current standard, as well as what is the likely non-compliance. So we had to use multiple factors to arrive at different emission factors for different age group and technology type in thermal power plant, and then add them together to come out with emissions of PM2.5 from thermal power sector. As we know the location of thermal power plants, we also have data on state-wise emission of PM2.5 from thermal power plants. We have done that for all industries, steel industry and cement industry, engineering industry. So almost all industrial sector, the major industrial sector, we have addressed. So this is the way, PM2.5 inventory for different activities of stationary fuel consumption and industrial processes was developed. We relied on one very important paper, which is a paper done by Kurukawa and Ohara. Now, this paper has basically developed, and they have been working for many years to develop regional emission inventory in Asia. And we have used their data of version 3, which is regional emission inventory in Asia, REAS version 3 database, as the base data for some of our analysis, not all of our analysis. And the reason is very simple. While we derived a lot of knowledge and methodology from Kurukawa paper, we also very clearly understood that it is a dated paper. The data is only till 2015, number one. Number two, they have underestimated the use of residential fuel, especially for heating, because no data was available. It is only now that we have much better understanding of residential fuel consumption, especially from heating perspective. So they have estimated residential fuel, and they have not taken into account open burning of agricultural residues. So considering these limitations, we had to overcome these limitations, but Kurukawa paper was important because it offered us a benchmark to gauge whether our results are way off the chart, whether they are underestimation or they are overestimation. So it is a very important paper for us in this entire exercise. I want to now go deeper into one or two sectors, which is of great interest to people. From what I have read on social media, of course, residential fuel is of great interest to people, and I want to explain how we arrived at PM2.5 emissions from residential fuel. See, we now have 20 years of data on percentage and number of households using different kinds of fuel for cooking and lighting. We have National Sample Survey, 58th round, which was published in 2002. Which has data on percentage and number of households, which is for select states and UTs. They have done an all India estimate, but few states are missing from 58th round. Then we have 68th round, which was published in 2010-11, which has a much comprehensive coverage, and it again gives us percentage and number of households using different kind of fuel. From biomass to LPG to cow dung to coal to charcoal, a comprehensive, matrix of cooking fuel that is used in India. And then we have the latest one, which is 78th round, which for the first time gives us data on heating. So cooking and lighting, we have 20 years data. And then heating, we have data only for 2020 and 21. So this was the base data. The number of households, which is using biomass, could be easily derived from National Sample Survey. So data number one. Then there was this very interesting paper which was published in few months back, which was done by large number of researchers from India and abroad, which is led by Navinya. This paper, and this was actually household survey. They did large number of household survey to arrive at heating and lighting fuel in India, as well as cooking fuel. So, and they have given us some estimate on the quantum of heating and cooking and lighting fuel being used in India, also state-wise. So we now have two major sources. We had two major sources. One was NSS, and then we had Navinya paper on biomass fuel, residential use of biomass fuel. And we have relied on emission factor, which is from one of the most highly quoted paper of Andrea and Marlet. And this paper, they are from Max Planck Institute in Germany, and they give us details about the different kind of gases and aerosol that are released from burning of biomass. So we used these three papers to arrive at biomass numbers. So let me repeat. We had number of households, state-wise, country-wise, for the past 3 decades. We now have some estimate in terms of real numbers on how much households, how much biomass households are consuming in concrete numbers, and we have emission factor. You put all of three of them together, and you will arrive at the PM2.5 inventory, of course, with certain corrections and certain assumptions. And this is what we did to arrive at residential fuel emissions. Agro-residue burning, again, the same methodology. The base data for us was crop production. And then we relied on two important papers, one which was published in 2010 by Indian Agriculture Research Institute. It was a paper by Niveta Jain and her colleagues, which looked at emission of air pollutants from crop residue burning in India. And this paper was published in Aerosol and Air Quality Research in 2014, but their estimates are for 2010. So important paper from methodological perspective, and a latest paper on air quality impact of crop residue burning in India and mitigation, which was published in Nature Communication recently. So these two papers were used as methodological basis. And again, we have used Andrea and Marlet paper as emission factor. So with crop production, we can estimate residue generation. With these two paper, we can estimate fraction of that residue that is burnt in the field. And then we can multiply it with the emission factor from Andrea and Marlet to estimate the quantum of PM2.5 that is being emitted from crop residue. It is sounding simple. It's a much more complicated process because we had to go crop by crop and state by state. But this is, in simplest term, this is the process that we had followed. Mobile source methodology is a little more complicated because the variables are much more. You have to look at the age of the vehicle, the type of the vehicle, the fuel type, number of vehicles which are in operation, distance travel, and emission factor. So there are multiple variables here to consider to arrive at mobile source emissions. Here, our base data was registered vehicle, but then we had to get to a factor to arrive at vehicles in operation, because after certain age, vehicles retire. So that retirement age we had to assume. And that we did from, again, two seminal papers that came out from IIT Bombay. One was from Apurva Pandey and Chandra Venkataraman, which is a little dated paper, but the methodology is very solid there. And the second is something which was published recently in 2010, again by IIT Bombay. So these two papers were the methodological basis for us to estimate transport sector emission. So this is what broadly the methodology which we have followed. And this is the result. When you put together this vast amount of data, this is what you get. the total PM2.5 inventory according to total PM2.5 emission annually, according to our research, is about 5.2 million tons, 5190 kilotons, total PM2.5. 48% comes from residential biomass, of which cooking is about 39%, heating is about 9%. So 48% of PM2.5 comes from residential biomass. And the answer is simple. There's no control device. If there was a control device on chulhas and cook stoves, this emission would have been much lower. But there is no control device. And that point one should keep in mind all the time. Crop residue burning, 6.5%, which is more or less similar to transport emission, which is 357 kiloton. In fact, heating fuel emission is more than power sector, 8.3%. And crop residue burning is similar to transport. That's another way to visualize the emission profile of the country. Industry is a big polluter. 29% of emission comes from industry. And if you add power plant, then you're looking at 38%. So 38% from industry and power and 48% from residential. You're looking at 86% of the emissions. 86% of the total PM2.5 comes from house or industry. And this is what the op-ed said, that let's focus on residential biomass and industrial emission, because that's where bulk of pollution is coming. And that led to a lot of comments, but I'll come back to those things, but those comments, and I'll try and answer, because some of them are really serious comments that needs to be answered. But this is what the PM2.5 inventory of India looks like. Now, we also have, as I said, Kurukawa paper, which has estimated pollution from 1950 onwards, especially for power, industry, transport, and residential and cooking. So we have decadal data from Kurukawa from 1950 to 2015, and we have done our estimation for 2021. Now, if you put together all this data, this is how the trend looks like. And this is a very interesting trend. As you can see, you can clearly see that we have a dip in residential cooking emission post-2010. The residential cooking PM2.5 emission peaked in 2010. And I will again explain to you in next slide in greater detail. But it peaked in 2010, and since then it is coming down. Industrial emission has not stabilized, it is increasing, whereas power and transport have stabilized and slightly coming down, which is common sense. Post 2010, we have Euro 3, Bharat stage 3, Bharat stage 4, and we have now Bharat stage 6. So some of the cleanest vehicles in India have come post 2010. So our fleet actually post 2010 is about 50 to 60% of the total fleet, which is at least Euro 3. So we have cleaner vehicles, we have retired older vehicles, and therefore you can see, while the number of vehicles have increased, but the emission standards are much more tighter, the performance of vehicles are much better, and therefore you do see a stabilization and dip in PM2.5 emissions from vehicles. And the same you see in power plants. Again, common sense, because we have two things have happened in thermal power industry. We have retired about 20,000 megawatt of old thermal power plants. Big number, 20,000 megawatts of most polluting power plants we have retired in last 10 years. And then we have new standards which have come in 2015. About 40% of thermal power industries are meeting those standards, 60% are not. So we do see 40% power plants meeting much more stricter standard, 20,000 megawatt of older fleet going out of service, and that is getting reflected in reduction in PM2.5 emissions from the power sector. So this is broad picture that is emerging. Not everything is lost, frankly. We generally think that nothing is improving. There is reduction that we can clearly see in residential cooking sector, as well as in power and transport sector. Marginal, but nevertheless, reduction that we can see in power and transport sector. Now, residential cooking, because a lot of questions were asked on residential cooking, and especially with respect to PM Ujjwala Yojana. That despite PM Ujjwala Yojana, how can 48% of PM2.5 emission can come from residential cooking? Okay, the answer is very simple. Between 2010 and 2021, 50 million households have moved out of biomass cooking as primary fuel. That's not a small number. In fact, in 2000, we had 150 million people who were dependent on biomass for primary cooking. In 2010, it became 160 million. Now we are 110 million. So in last decade, 50 million people, 50 million households, I'm sorry, I keep saying people, household, 50 million households have moved out of biomass cooking as primary fuel, biomass as primary cooking fuel in last 10 years. And that is getting reflected in emissions. Our emission in 2010 was 2.3 million tons. It is now 2 million tons. And therefore, from biomass cooking, we have reduced emission by about 0.3 million tons, which means that the shift in cooking fuel is the biggest action on air pollution. Nothing comes even closer. So the shift that has happened from 160 million household to 110 million household between 2010 and 2021 has also happened because of PM Ujjwala Yojana. That 0.3 million ton PM2.5 emission is the biggest action on air pollution in India. It is not transport sector or industry sector. No sector can claim to reduce so much emissions. But the quantum is so high. 2 million tons, is the current emission from biomass from cooking. So 0.3 million ton is not making any dent. We still need to do more. We need to get all 110 million households, out of biomass cooking. Then you will see significant improvement in air quality. But make no mistake, there has been reduction in PM2 pollution, PM and other gaseous emission, reduction from residential sector because of shift in cooking fuel. Auto emission, there were comments which said that we have underestimated auto emissions. I have put together 4 studies on automobiles, emissions. 2010, Pante and Venkataraman, whose methodology we have used, they estimated PM2.5 emission from automobile sector as 276 kilotons. Kurukawa estimates it as 428 kiloton because it has used a much more generic emission factor. Namita Singh, the latest paper from IIT Bombay, actually estimates it to be 164 kiloton. And we now know why their numbers are a little lower. Our estimation is 357 kiloton. So there is absolutely no reason. We have used, and in fact, the previous 3 papers have helped us to refine the methodology and emission factors to arrive at these numbers of 357 kiloton of PM2.5 emission from the auto sector. One interesting analysis which came out from this entire thing was the impact of crop residue burning and heating fuel on air quality. Now, our research essentially shows the following, that the 3 most important crop whose residues are burnt is paddy, wheat, and sugarcane. And then you have rest, which contributes about 20% of all the crop residue that is burnt. So paddy is 40% of all the crop residue that is burnt. We burn about 100 million tons of crop residue, so 400 million tons. Not only in Haryana, Punjab, Uttar Pradesh, and Rajasthan, but also now more and more in Madhya Pradesh. we are burning, paddy residue. It's about 400 million tons, 40 million tons. Wheat, about 20 million tons, which happens in April and May, and paddy during October, November. Sugarcane, about 20 million tons, November, January, and the rest about 20%, 20 million tons from December to March. So we know the quantity and we know the months when agro-residue burning broadly takes place in India. We also know about heating fuel, that about 50% of heating fuel is used during winter, which is December, Jan, and Feb. Western India, for example, uses heating, and Southern India uses heating fuel throughout the year. But if you look at Indo-Gangetic Plain, the hot spot of pollution, most of the heating fuel is used during December, Jan, and Feb. So we know these. So these are the two numbers I wanted to place before you. Now, this is the PM2.5 ambient air quality concentration in Delhi from 2018 to 2022. As you can see, we have peak in January and February. We have a little peak which happens in April and May, and then we have October, November, and then December. And this is pretty consistent over the last 5 years. If you put 10 years also, you are likely to see the same trend. Now let's superimpose the PM2.5 emission from crop residue burning and heating fuel. And this is what you get. The maximum amount of crop residue burning and biomass used for heating actually happens in October, November, December, Jan, and Feb. That is the period. We know October, November, paddy. December, Jan, you have sugarcane entering the field. And this is how it looks like. So there seems to be a significant correlation between the seasonal pattern of crop residue burning and heating fuel and its impact on air quality. It needs further investigation, but it seems that heating fuel as well has significant contribution to the peak in emissions that we see during winters, as well as crop residue burning. So I just wanted to place this because this could be an area of further research for all the researchers who are working on air pollution. So what are our recommendations? Let me now end my presentation with these recommendations. We have essentially said that focus on residential fuel. It is a pro-poor agenda. There is 8 lakh premature death that happens every year from indoor air pollution, largely in households that use biomass as cooking fuel. So the impact of biomass cooking is very high on the poor. The rich has moved to LPG, and the middle class, they'll also move to electricity. But there is large number of poor people who are on biomass. So from indoor air pollution, health of women itself, it makes sense to move these people out of biomass as cooking fuel through all the support and incentive that is required. Programs like PM Ujjwala Yojana, if it is modified a little bit more, will help a lot. But it will also lead to reduction in air pollution outside. Ambient air pollution will also reduce. 48% is coming from residential cooking and heating. So this is, if there is one developmental agenda, a co-benefit agenda, a pro-poor agenda, it is to move people out of biomass as cooking fuel and heating fuel. As I said, so far we have, shifted 50 million households between 2010 and 2020. But if we want to meet the Sustainable Development Goal 7, which India has promised, SDG 7 goal, that we will provide clean cooking fuel to all households by 2030, which is next, another 6-7 years, then we will have to triple the rate of providing cooking fuel. We have done 5 million households every year. We will have to do 15 million households every year over the next 7 years to meet SDG 7 goal. But as I said, it is it is a perfect development co-benefit agenda and a very pro-poor agenda that we should adopt. Second is eliminate crop residue burning. It will give immediate relief of all the hazardous and severe air pollution days that we see. We can link it to the number of farm fire. So it will give us immediate relief. If we stop residue burning next year, you will see the impact on air quality next year. It's a technological issue. I have written about it, that the problem is combined harvester and the solution will also be a combined harvester. You can read my op-ed on this in Times of India. I'll not go into that, but we will have to use incentives and disincentives to do it. Farmers are demanding 100 rupees per quintal, which will be about 2,000 crore rupees. I think it's worth it. To save the lives of millions of people, to give 2,000 crore rupees to farmers to manage stubble is a worth investment. And incentives should be there, but there should also be disincentives. If farmers are still burning crop residue, then we should think about not buying their crop through government schemes like PDS. Again, this is a pro-farmer agenda, because we are not looking at the long term, which is the impact of farm fire on soil, environment, and farm sustainability. Leave air quality and the health impacts. Again, a pro-poor agenda, pro-poor, pro-farmer agenda. Power sector and industry, I think somehow, it has gone out of focus. There is a perception that industry is no more a problem, that we have solved the industrial pollution issue. Not true. While bigger industries have put pollution control equipment, there are a large number of small and micro enterprises who need help in putting pollution control equipments. We need to strengthen compliance and enforcement. And we need, frankly, to make energy transition in the industry sector. And to start with, shift small and medium scale enterprises to electricity. So this is another big agenda. And lastly, a transition which is already happening, which is to move to green and shared mobility, whether it is EV, public transport, walking, NMT. This agenda has been there for 20 years. We should now make sure that it gets done. So these are our broad recommendations on this study. And that ends my presentation. Now, as I said, I have few questions that I have picked up from social media, important question that I want to answer before I take your questions. Question number one, essentially, which many people have asked, that if biomass is such a significant source of PM2.5, then why air was clean during COVID-19? During COVID-19, we have all industries were shut down. Hardly any vehicles were on the road. Power plants were operating at lower capacity utilization factor. And therefore, there's a very important question many people have asked, that if cooking fuel is such an important source of air pollution, then why the air was clean during COVID-19? Okay. Let me answer this. Now, I'm sure many of you would have seen this publication by Central Pollution Control Board, which is a report on impact of lockdown on ambient air quality. Now, let me give you the snippets of the report and my analysis. See, the peak lockdown happened in March and April of 2020. Sorry. Okay. Now, these are some of the least polluting months in India. And I will take you back to this graph. Okay. You have decline in pollution generally. In fact, these are the least non-monsoon polluting months. The meteorology is less adverse, the wind is blowing, and therefore you have low pollution during March and April. So point number one, remember this. When COVID-19 lockdown happened, it happened during the period when the air quality is generally good. Okay. The second is, as I said, the entire industry was closed. Power plants were operating at low capacity utilization factor, and therefore contribution of pollution from these sectors were less. Okay. But what was the air quality? Now, this report gives data on 12 cities, ground-based monitoring, and shows that the PM2.5 actually was between 25 and 50 microgram per meter cube during this period. So it wasn't clean days. While the sky looked blue, it wasn't a very clean, the air was not actually very clean. And then you have satellite-based monitoring again in this report, which shows that the all India average of PM2.5 actually was 59 microgram per meter cube. Our standard is 60. Daily standard, annual standard is 40. Now think about it, when all the industries were shut down, all vehicles were stopped, and still the PM2.5 average all India was similar to daily national ambient air quality standard. We were barely meeting the standard. So what is the source of this pollution? Is obviously the major economic activity during that period, which is, daily, activity that happens in houses, cooking and some agricultural activity. So the question itself answers it, that actually COVID-19 clearly established the impact of cooking fuel on India's air quality, that it is significant. So therefore, the answer is simple. Actually, COVID showed that biomass has significant impact on the air quality. Question number two. Again on biomass. If biomass is such a significant source of PM2.5, then why air was not so bad in past? What was air quality in 1950? As I said, we have long-term historical data estimated by Kurokawa and his colleague, and this is how it looks like. Actually, biomass contribution to PM2.5 was close to 1 million ton in 1950. At that time, our population was 350 million people. In 1990, the contribution of residential cooking was as much as it is today, 2 million tons. So there was pollution. It's just that we did not recognize or did not talk about pollution during those periods. We called smog fog, but there was pollution. So it isn't that India was not polluted. The air quality was very good 30 years back. It was just that we were not discussing these issues. These issues had not come at the forefront, but there was significant contribution of PM2.5 then also. So this graph shows that the air quality, wasn't very good even 30, 40 years back, as far as contribution of PM2.5 is concerned, in terms of, residential cooking. So these are the questions I wanted to answer, because, the biomass became a big issue. People felt that, focusing on biomass was taking agenda away from automobile. The answer is it should take focus away from automobile, simply because biomass is a big agenda. It is a pro-poor agenda, and we need to address it. And so is industry. Industry itself is a big agenda. So I finished my presentation, and now I'm going to take